Okay, so let's continue our study of the quadratic formula. So I found this and I just wanted you to show how the quadratic formula relates to everything you need to know about a quadratic. So to review, when we have a function in standard form, the value of c is our y-intercept. Notice our negative b over 2a is part of our quadratic formula. That's the value of our vertex. Our x-intercepts, we talked about, we can factor, but not every quadratic is factorable. The quadratic formula will always solve, find the roots, the solutions, or determine the x-intercepts of a quadratic. Okay, remember those four terms are synonymous. And then we didn't talk about this term as indiscriminate, but we did talk about what's underneath the radical. If it's positive, that number, then you have two solutions, two x-intercepts. If the number underneath the square root is equal to 0, we only have one x-intercept. And if this is true, the x-intercept would actually be the vertex as well. If what's underneath the square root is a negative number, there's no solution. So the graph will never cross over the x-axis. All right, use the quadratic formula to find the x-intercepts of this function. So we have a is equal to 4, b is equal to 3, and c is equal to -1. Opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. From the work you submitted for me to check, it was pretty good. You did okay with these minor mistakes, but that'll work itself out with practice. All right, so -3 plus or minus the square root of 9. -16 times -1 is a plus 16. -3 plus or minus the square root of 25 all over 8. Okay, so for the work you did yesterday, I said you could leave this. But for a problem like this, you should notice that 25 is a perfect square. So I can evaluate that further, and I know the square root of 25 is 5. So you're expected to be able to do that. And we'll talk about approximating solutions today. Now let's get our answers. So the number underneath the radical was positive, so I better be able to get two solutions. Where do my two solutions come from? That's the significance of this plus or minus. Now let's finish this. So what that means, I take -3, I add 5 to it, and then divide by 8 for one solution. Then I take -3 and subtract 5 from it and divide by 8 for the second solution. So that plus or minus, you're not going to find a plus or minus button on your calculator. That plus or minus is what tells you that two answers exist. -3 plus 5 is +2. 2/8 reduces to a fourth. -3 minus 5 is -8. Divided by 8 would give me -1. So what are my x-intercepts? My x-intercepts are at the point 1, 4, 1/4, 0, and -1, 0. Okay, let's look at another one. Now I'm going to approximate the solutions. So a is equal to -3, b is equal to 1, c is equal to 5. X equals opposite of b plus or minus square root of b squared minus 4ac all divided by 2a. Let's plug our values in. B squared, 4ac. I would suggest that you write out the values of a, b, and c until you really are getting every single problem perfect. Okay, if you made any mistake on what you turned in the other day, then please take them 10 seconds to write down the values of a, b, and c. So square root. -4 times -3 is 12. 12 times 5 is 60. All over -6. Okay, -1 plus or minus the square root of 61 divided by -6. Okay, so again, the first thing I had you do, you'd be totally fine leaving it like this. Now we're going to practice using the calculator and actually approximating these solutions. So that plus or minus, remember that tells us two solutions exist. So I have -1 plus the square root of 61, all divided by -6. And then I have -1 minus the square root of 61, all divided by -6. So let's pause the video, grab your calculator, and let's work on evaluating these. Okay, so first I'm going to show you the right way to do it. Then I'm going to show you a common mistake. So when I enter this, -1 plus, now on a graphing calculator, the square root, it's above the x squared. So I have to hit second x squared. There's my square root, 61. Now notice my cursor is still underneath the radical. So I'm going to move that over, end the parenthesis, and then I'm going to divide that answer by -6. So -1.14 is one solution. Okay, so then I'm going to get my next solution. So everything stays the same, except now it's -1 minus the square root of 61. Move my cursor out, end the parenthesis, divided by -6. Okay, so 1.46 would be my second solution. This is a very common mistake that students make. Notice how the answer will change if I don't include parentheses. So there's my -1 plus square root of 61 divided by -6. So what the calculator did is it took square root of 61 divided by -6 and then added -1 to it. Because according to our order of operations, division comes before addition. The other way you could do it and get the right answer, I could do -1 plus the square root of 61, get my answer, and then I take that answer and divide it all by -6. And now you see that we get the same one that we got the very first time when we used parentheses. You have to practice with your calculator. You have to be perfect with these. Okay, so those are our two approximate solutions using the calculator. All right, let's look at the next one. A is equal to 6, B is equal to 5, C is equal to -2. And notice I changed my, just so you guys would see it, I asked for the solutions here, right? On the previous problem, I asked you for the x-intercepts. Because again, I just need you to remind yourself that these are the exact same steps. All right. Now, notice on this one, I'm not checking for factoring because I just want to go through how to use the calculator. But the more we work on this, I will be doing both methods. As a good problem solver, when you hear approximate, then an approximate solution will need the calculator. It won't be a factorable problem anyway. Opposite of b, plus or minus the square root, b squared minus 4a times c, all divided by 2a. Okay, opposite of b, b squared, 4ac, all over 2a. 25 here. Then I have -24 times -2, so that would give me a positive 48, all divided by 12. If I add 50, that gives me 75, minus 2 would be 73. Okay, so underneath the square root is positive. That's a good thing. So what I would like you guys to do, I'm going to break it up. Okay, here's my plus or minus. -5 plus the square root of 73 divided by 12. -5 minus the square root of 73 divided by 12. So I want you to approximate these and then send your solution through a Teams chat. Give me the 2 decimal answers and send me the answers that you get using the calculator. All right, number 4. Now notice I changed the word again. Okay, the roots. So x-intercepts, solutions, roots, all synonymous. We do the same thing. I set y equal to 0 and I solve for x. Okay, so notice the form's different. All right, so the quadratic formula, I use all the problems we've looked at. Sorry, my computer. Ax squared plus bx plus c. All the problems we use the quadratic formula for, my original expression was written in standard form. I'd like you to answer to yourself, what form is this problem written in? Well, this is vertex form. So sure, you could square that, you could distribute the two. We've talked about going from vertex to standard form, but way too much work. I can go right to solving this just by getting the squared piece on one side of the equal sign and the number on the other side of the equal sign. How do I do that? First thing, I'm going to add 8 to both sides of the equation. Next, I'm going to divide by 2. So I get 4 is equal to x minus 4 quantity squared. Okay, so standard form, factoring or quadratic formula. Vertex form, let me isolate, let me get alone that piece that's being squared. Okay, now what do? We got to take the square root of both sides. We've talked about this at length in class, but it is something that is easily forgotten. When I take the square root of a number, remember that 2 values exist, my positive and my negative. Why is that plus or minus important? Where have we seen that? We see that with the quadratic formula, that negative b plus or minus. So what this tells me is that really I have 2 little equations I have to solve. X minus 4 can equal positive 2, or x minus 4 can equal negative 2. So there's that plus or minus again. I'm breaking that up into, here's my positive answer. I don't write the plus. There's my negative answer. Just like if I were to use it with the quadratic formula. Add 4 to both sides, so x is equal to 6. Add 4 to both sides, or x is equal to 2. So the roots of my solution would be 6 and 2. All right, do I have one more in here? Okay, so now solve. So here I am again. I'm using the 4th phrase. Okay. Solutions, x-intercepts, roots. Solution, x-intercept, root. Okay, so I'm going to set y equal to 0. Now I am going to check to see if this is factorable. A is 3, B is 5, C is negative 2. Okay, so 3 is a prime number. The only factors of 3 are 3 and 1, so that's nice. So the only way I can multiply to 3x squared. Okay, so 3x squared, I have 3x times x. Now, 2 is a prime number. The only factors of negative 2 are negative 2 and 1, or 1 and negative 2. Now remember, I have to multiply to a negative, but add to a positive. The only way I can multiply to a negative is if my signs are opposite of each other. So I'm going to try plus minus. So I'm going to guess the order. I'm going to put my negative 2 here. I'm going to put my positive 1 here. Because I know that negative 2 times 1 gives me my negative 2. So all I have to check are my middle terms. Here I get 1x. Here I get negative 6x. When I add those together, they add to negative 5. Well, what do we need them to add to? Positive 5. So I'm in good shape. The only thing I have to change, I got to change these. So it should be positive 2 and negative 1. Then I get 3x times 2 is a positive 6x, negative